Hi everyone, so today we're going to be working with solving exponential and log equations, and then we're also going to have our quiz review for our quiz on Friday, which is tomorrow. So the first thing we're going to do is a homework review. So in this problem, the key here is whenever you see continuously or continuous, then we're going to use the PERT equation, PE to the R times T power. So here we have to just break it down. So we're going to take the initial amount, which is 4,000. So principal is 4,000. Our rate always has to be a decimal, so we're going to convert 3% to a rate, which is 0.03. And then we want to know the time, which is 4 years. So t is equal to 4. Then we're just going to plug it into this formula. So 4,000 times e to the 0.3 times 4 power. What I told you guys yesterday is make sure we simplify the exponent first. Do 0.03 times 4. We do that and we get 0.12. Once we get there, we are going to do e to the 0.12 power. Round that number to 4 decimal places, so I get 1.1275. Now take this number and multiply that by 4,000. When we do that, we get 4,510. This right here is your final answer. This step here, right before the final answer, the 4,000 times whatever e to that exponent is, this is probably the most crucial step here. If you do not show me this step, our answers, like even on the homework last night, some of us, our answers might slightly differ depending where we round it in this step right here, especially the step inside the parentheses. Where you round and where I round might not be exactly the same, so our answers will slightly differ. So make sure you are showing me this work right here. So that way, if the answers do differ, I know where you're coming from with them. So in the second problem, if someone invested $10,000 at 4.5% interest compounded continuously, how much will they have after 8 years? Principal is 10,000. Rate is 4.5 or 0.045, and their time is 8. Plug everything into this formula. So 10,000 times e to the 0.045 times 8 power. First things first, do 0.045 times 8, and we get 0.36. Simplify e to the 0.36 power, and we get 1.4333. Then we're going to multiply this number times 10,000, and at the end we get 14,333 as our final answer. How about this one? If someone invests $2,658, it's compounded continuously at 9%, how much will they have after 15 years? Well, our principal is 2,658. Our rate is 9% or 0.09, and their t is 15. Plug it into this equation. So 2,658 times e to the 0.09 times e to the 0.09 times 15 power. Simplify 0.09 times 15, we get 1.35. Do e to the 1.35 power, and we get 3.8574. Now go ahead and multiply 2,658 times 3.8574, and we get $10,252.97. Now let's try this one. Someone invests $6,154 in a savings account with the annual interest rate of 8% compounded continuously. What will the account balance be after 10 years? Same thing. Principal is 6,154. Our rate is 8% or 0.08, and our t is 10. Plug it into the PERT formula. So we get 6,154 times e to the 0.08 times 10 power. Do 0.08 times 10, we get 0.8. So then next step, we're going to do e to the 0.8 power, and we get 2.2255. And then we're going to multiply that by $6,154, and we get $13,695.73 as our final answer. The next thing we're going to start is our new lesson. So what would happen? Here we're going to be solving for x. I give you 10 to the x power is equal to 45. So what this question is asking is 10 to what power is going to give me 45? There's really no way to solve this really quickly in your head. So the easiest way to do this is convert this as an exponential form. We're going to convert it to log form. So this is our base, exponent, answer. Log form goes log, base, answer, exponent. So we just write it. Log base 10 of 45 is equal to x. Now we know how to solve this problem. You were doing it last week on your quiz. We're going to solve this to get x using the change of base formula. And we're going to do log 45 divided by log 10. And when we go ahead and do that, we get 1.653. So if we wanted to check it, 10 to the 1.653 power should give us 45. Now how about this one? Now what if I give you 4 times e to the x power? 4 times e to the x power is equal to 178. So e to what power? 4 times e to what power is going to give us 178. The easiest thing to do first is treat this as a giant x. Treat this e to the x as one giant x. How would you get x by itself? The first thing you would do is divide each side by 4. When we divide 178 over 4, we get 44.5. Now we know how to set this one up. Now we could put this into log form. So we do base, exponent, answer. Log base e of 44.5 is equal to x. We're looking for x, so we need to solve this log. Now, we're going to use the change of base formula, but what did we say log base e could be replaced with? ln. Remember, log base e is equal to ln, and ln is equal to log base e. So we go ahead and change this log base e to ln. So now we're going to do ln of 44.5 is equal to x. We just type in our calculator ln 44.5, and we get x is equal to 3.796. Now on your quiz, I'll be sure to tell you where we should be rounding to. Now how about this one? 3 times e to the negative 2x is equal to 294. What should we do first? Divide each side by 3 to get e by itself. So when we divide each side by 3, we're left now with e to the negative 2x is equal to 98. Okay, now just convert this to log form. So log e of 98 is equal to negative 2x. We replace log base e with ln. So now we're left with ln of 98 is equal to negative 2x. In your calculator, now do ln of 98, and we get 4.58 is equal to negative 2x. So how are we going to get x by itself? Well, we got to divide each side by negative 2. And when we do that, x is equal to negative 2.29. So basically the ultimate goal is you're solving for e here. And then once we solve for e, you put it into log form. And anytime you have log base e, you replace that with ln. So then we just do this in our calculator. And then solve for x. How about this one? 5 times 9 to the 2 times x power plus 6 is equal to 21. First thing I would do is subtract 6 from both sides. So when we do that, minus 6 over here, minus 6, now we're left with 5 times 9 to the 2x power is equal to 15. Next, we're going to try to get this 9 to the 2x power by itself. So what do we have to do with this 5? Divide each side by 5, and now we're left with 9 to the 2 times x power is equal to 3. Now we can go ahead and convert this to log form. So now we have log base 9 of 3 is equal to 2x. When we do that, this right here, we can use what? The change of base formula. So we're going to do log 3 divided by log 9, and we get 0.5. So now we're left with 0.5 is equal to 2x. We got to solve for x. We got to divide each side by 2. And when we do that, we get x is equal to 0.25. So now we're going to cover something called the one-to-one property of logs. Basically, the definition of that is log base a of x is equal to log base a of y, then x is equal to y. So what that is saying, as long as the bases are the same, so this is log a, and over here, this is log a, you could set the logs equal to each other and solve. We're going to go over what that means in just a second. So this is the one-to-one property. As long as the bases are the same, then you could say whatever number is over here, you could set them equal to each other. So let's try this one. Log base 2 of 8 is equal to log base 2 of w. So we check this out. I just rewrote it. So we have log base 2 over here and log base 2 over here. Going back to the slide, when the bases are the same, base A, then we can set x equal to y. So now bases are the same. Same thing over here. Log base A, then x is equal to y. So now we could set these two equal to each other. So now we could set 8 is equal to w. This one, we just have to solve for w. There's no work here because w is already by itself. So here our answer is 8. So log base 2 of 8 is equal to log base 2 of w, and w is equal to 8. If we wanted to check it, plug it back in. Do we get the same thing? Yeah. So we both get log base 2 of 8 is equal to log base 2 of 8. So then we know this works out and it's true. How about here? How about if I give you log base 6 of 2x plus 8? It's equal to log base 6 of 3x. I rewrite it. We notice our log, it's both log 6. So now we could set whatever's next to it, whatever's in the parentheses, equal to each other. So 2x plus 8 is equal to 3x. Now we know how to solve this problem right over here. We're just basically now going to go ahead and solve for x. How are we going to get x by itself? Subtract 2x from both sides, and we're left with 8 is equal to x. Once we get to this step, we have to plug it back in to check to make sure we're not going to get a negative answer, or to make sure that they're both the same on each side of the equal sign. So wherever there's an x, I go ahead and plug in 8. So now you kind of ignore this log 6. So now I do 2 times 8 plus 8. So 16 plus 8 gives me 24, and 3 times 8 gives me 24. So we're left now with log base 6 of 24 is equal to log base 6 of 24. They're both equal to each other, so our answer is a valid answer though. I'm going to go over in just a second what happened when they don't equal each other. So now for the next problem, we have log base 4 of negative 4x plus 7 minus log base 4 of 2x minus 17, and it's equal to 0. The first thing you want to do is you can't use the one-to-one property because it's log minus log. So we gotta bring the log over here. So we gotta bring it to the other side of the equal sign. The only way to do that is to add it. So now we're left with log base 4 of negative 4x plus 7 is equal to log base 4 of 2x minus 17. They both have the same logs or same basis, so we could set them equal to each other. So now we have negative 4x plus 7 is equal to 2x minus 17. Combine like terms, so we're left with 24 is equal to 6x. Divide each side by 6, and we get our answer, x is equal to 4. But remember, for these, we have to check them. So I just go back in and plug wherever there's an x, I'm going to plug 4. So now I have log base 4 of negative 4 times 4 plus 7 is equal to log of 2 times 4 minus 17. So when I do this, negative 4 times 4 is negative 16 plus 7. Negative 16 plus 7 gives me negative 9. Whoa, I stopped there. Why am I stopping? Because now we have log and we have a negative 9 right here. If you remember, sometimes when I give you guys questions, it will pop up and it will say no solution. You can't take the log of a negative number. So because of the negative sign right here, there is no solution. This problem the x cannot be equal to 4. Why? Because when we solve it, or when we plug it back into check, we get a negative number. Negative numbers aren't going to work when we go back in and check. So this problem has no solution. So now we're going to do a quiz review. So the first thing that I could give you on your quiz, I could give you this to evaluate. E to the negative 4.3 power is equal to what? Plug it right into your calculator, and then we would get, round it. Here I rounded to 4. On your quiz, make sure you read the directions. I'll tell you what place to round to. So our answer is 0.0136. How about this one now? 3 times e to the 0.03 power. All I'm going to do first is simplify e to the 0.03 power, and I get 1.0305. Next, I'm going to multiply this number times 3, and I get 3.0915 as my final answer. Now, this is the key to remember here. Anytime you see log base e, it's equal to ln, and anytime you see ln, that's equal to log base e. So, also in your quiz tomorrow will be some word problems with e. Those are like the problems we went over on Monday with population growth, tracking how much medication's in a patient's body after X amount of times, radioactive decay. All of those problems can be on the quiz. The only thing about those is you'll have the formula and you'll just be plugging in to solve. So if I give you a word problem and it has E, formula is going to be there. You're just going to be solving for maybe a certain time period. How about now if I give you ln of 56.3? All we do here is plug this into our calculator and we get an answer. Our answer for this problem is 4.0307. How about if I do this? E to the x is equal to 25. How are we going to solve for x? First thing we're going to do is plug it into log form. So log base e of 25 is equal to x. Remember from a couple slides ago, I told you log base e, you replace it with ln. So now we have ln of 25 is equal to x. Plug ln of 25 into your calculator, and we get 3.219 as our final answer. So we can also have continuously compounded interest on the quiz. That's the problems we went over at the beginning of this lesson. As a reminder, anytime you see continuously compounded, we're going to use the PERT equation.